Welcome everybody. My name is Debbie Repko, and I am the Application and Technical Support Manager for BUCHI Corporation, supporting the US and Canada. And today's webinar is entitled Put It on Ice. And we're not talking about champagne and or craft beer. We are talking about our new freeze dryers and putting your samples on ice. Our objective today is to give a little introduction to our freeze dryers that were launched last year and to supply some information of the technology. So we're going to talk about why to freeze dry, the principles of lyophilization, steps in the process itself, sample preparation, configurations, sensors to endpoint determination, and the software behind the system. Okay. So why freeze drying? The whole point is to remove water from your sample. By doing this, I'm going to increase the shelf life stability of the product that we want to freeze dry and or preserve something for long term. The lyophilization process makes highly porous products so that I can reconstitute them later and easily. Okay. Typically speaking, I'm freeze drying products that are temperature sensitive, okay, and something that maybe I don't want to see oxygen. What is freeze drying or lyophilization? So by definition, coming from the dictionary, lyophilization is the process of preserving a sample by freezing it quickly and then subjecting it to a vacuum to remove the ice by sublimation. And we'll talk further about what sublimation is. We can do freeze drying in a very basic sense by taking a frozen sample, putting it on a manifold configuration on a freeze dryer. And the heat that it's going to see is simply from the ambient air. So it's getting convection or radiation from the atmosphere. I can do more advanced freeze drying where I have ultimate control of the temperature of the condenser, the internal pressure, manage my time through software control. Okay. Here's a nice phase diagram of all states of matter of water. So I have solid, liquid, and gas. I have pressure on one side, and I'm applying temperature on the other. My sample A is frozen, and sublimation takes place at low temperature and low pressure within this pink phase, or C. And it needs to take place under the triple point. So all phases of matter, of water, are at this triple point. So the line going here is that sublimation front, and that's where freeze drying takes place. Okay. This is a graph showing the freeze drying process steps. So freeze drying has three primary steps: freezing, primary drying, and secondary drying. And this process takes time. It could take up to several days or even longer, depending upon what I'm trying to dry. All right, thank you, everybody. So 60% of you are saying no, that you don't have freeze drying presently, and 40 of you do. Good, thank you. Okay. Part of the process is sample preparation, and I have to pre-freeze my samples, whether I'm doing this in bulk, with vials, or in flasks. Typically speaking, most people are using an external laboratory freezer. I'm just going to put my samples into this freezer for overnight, and in the morning come in and start my process. I could also typically use liquid nitrogen. And if you have a rotary evaporator, you could use our new freeze drying bath, which I'm going to show on the next slide. So if you have an R300, we have this new freeze drying dewar, so to speak. It fits onto your B300 heating bath base. And the advantage of doing this is that I'm going to create a nice shell on the flask itself, so it's nice and thin, so the sublimation front works more quickly and dries more quickly as well. So we have two different freeze dryers. We have the L200, which is a classic, basically bench top laboratory freeze dryer. I have the dimensions listed here. We have a basic system and a pro system where I can use software to monitor it, or an L300, which you can see is a little bit larger. It's a continuous system and also has software control. It's not quite, but almost twice as large from a footprint perspective as the L200. The L200, like I said, is a classic laboratory size instrument. It has a condenser temperature, which goes down to -55, which is pretty normal. The condenser is 6 kilograms, which is a nice size for the lab. It can be set up on a trolley, which is shown here, or sit right on a bench top itself. The wheels make it mobile, and the vacuum pump can fit on the bottom of this trolley. I can remove my drying cylinder or my manifold and easily get right inside to the condenser coil to clean it, which is pretty nice as well. Has quick cooling time. And I have flexibility in my configurations, which we'll get into further into the presentation. I can configure my system to have a pro interface, meaning software. Here are the dimensions, and I want to say that it weighs 75 kilos. The L300 has a -105 condenser temperature. That's fairly unique on the laboratory scale instrumentation. In addition, which makes this instrument very special, it has infinite condenser capacity because it has dual condensers. And I will also get further into this. It also has automatic steam defrosting and cleaning. It's always ready because it's never going to need to be defrosted. I have a software package to give me full control. And again, I have the ability to configure this based upon my needs. As I mentioned, the footprint is a little bit larger and it weighs 250 kilograms. It's fully, got 4 wheels on it, so I can move this around with ease as well. Here's a depiction of the dual condensers. And it's sort of a cutout, so it lets you see the front or the inside of the instrument. So on my right-hand side, I have one condenser that's basically full of ice, and that's where the phase is collecting. The other condenser is being steam cleaned and defrosted. Once the other condenser is full, the other picture is showing basically the top side of it, and that mechanism is going to open one and close the other, continual mode, and really lets us operate more like a pilot system than a laboratory freeze dryer. All freeze dryers have similar parts, so we're going to go through them. So I have a drying chamber that sits on the top that holds my samples. My vapor phase, as the pressure comes down, is going to move into the condenser space below. I have a control panel to the right that lets me set what's needed in the system, or the software will do that. My ice condensers are below, as you can see, and I need an external vacuum source. We have two different vacuum pumps. The Duo 6 has been procured to work with the L200. I don't need as much power because it's a smaller unit. Where the L300, I need a more powerful vacuum source, and this is the Duo 11. And these can be fully configured into your freeze drying system. Now we're going to move into configurations. Okay. So I can configure my system with 12 or 24 manifold configurations if I have the L200, because I'm limited by my condenser space, where the L300 I could use up to 36 position. Manifold configurations are really for basic freeze drying needs, and what's nice about a manifold configuration is that I can share this with my team members without disturbing their runs. I can be done, and you can be just starting yours. Here are a couple of accessories that we offer with the manifold system. We have flasks in a couple of different sizes, ranging from 100 up to 1.2 liters with appropriate adapters. We also have a distributor for ampules, and it can hold up to 11 different vials, 19 vials with it. And we have special adapters for the 2440 joints, which is typically what we use in the US and or Canada. Now we're going to move into the drying chambers that are available. And the first set, we're going to talk about unheated shelves. So we can configure the system with either 4 shelves or 6 shelves, and these shelves are completely adjustable. If I have a larger vessel, I can remove one of the shelves so that I can have larger jars, maybe something in bulk. In addition, I have a cover with optional 12-position manifolds as well. Moving on to drying chambers with heated shelves. And this is where we start moving into more advanced freeze drying. Once again, we have the ability to do both 4 and 6 shelves. Again, with manifold of 12 on top, and that basically sits on the top cover of each. In addition, we have a 4-position, which can do vial stoppering, which I'm going to talk about in a little more detail. Just want to say that every shelf is set at the same temperature with a maximum of 60. Each shelf individually has its own temperature sensor, which I would place inside a product in each of the shelves. So when I showed the graph of the freeze drying, we saw that we're converging our shelf temperature with our product temperature. So that lets us know when sublimation is finished. This is just a quick depiction of the stoppering. So essentially what you're going to do is you're going to take this handle and crank it down to close the tops of each of the vials, and the top shelf is going to come down and carry this a little bit further. So each of these vials have special stoppering lids sort of have a vent or an opening in them so that when sublimation starts, that vapor phase or that water vapor phase can escape, get to my condenser. When sublimation is completely finished and my product is nice and dry, I'm going to start the stoppering process. I would aerate the system first. I could also backfill with nitrogen if I want to keep something nice and inert and more pure. I'm going to completely close it. And then I could open up the freeze dryer to retrieve my samples that will be kept sanitary. So now we're moving to the end of the freeze drying process, which is the end point. With our systems, it can be determined in 3 different ways. One is called the temperature difference test, and it's just as you would think it would be, that the sample temperature and the shelf temperature have now come to the same temp, which I've set, and no more sublimation is taking place. A little more advanced way to do it is called the pressure difference test, and I would need to configure my system with both a Pirani and a capacitive sensor, and these are connected to the drying chamber. And once again, as soon as these same temp sensors come to the same result, the endpoint is reached. And then unique to just the L300 is a pressure rise test. So remember, we had these 2 valves that opened and closed on my dual condensers. Both of these valves are now closed. There's no more pressure increased, and it's sensing that sublimation is finished. With the pro versions of these instruments, I have the ability to have complete software control. What is nice about this is I do not have to have a bulky workstation. I can be at, in the lab itself. I could be at my desk. I could be at home, so that I can make methods or edit the methods. I could watch what's going on live from home as well. I have customized reporting. It just makes for a more complete system. To sort of keep up with the times, a couple of years ago when we launched the R300 Rotavapor, we had a mobile app that could notify you that your Rotavapor was, finished its process, and it would notify you if anything went wrong. So we've done the same thing for the Lyovapor product lines. It's through the same app, so it's available on your phone as well. It's now available on your desktop in case you don't want to have a phone stuck to yourself all the time. But it's going to let you know that something has gone wrong, and you can actually stop the process from your phone or your desktop. Like the Rotavapors, we also have a configurator on our website to configure your Lyovapor system. This would let you go step by step to pick the system. If you want to add whatever configuration you want, it's going to build the system for you with a part number so that you can ask for a quote or just browse it to see what exactly we have to offer. And this is also available on a mobile app. Today's webinar is a shorter one, which is fine. The idea was just to kind of give you a nice summary of our Lyovapor systems. Wanted to let you know that I did upload a couple of different documents, the technical data sheet for both the L200 and the L300. There is a nice technical document called the advisor, and a lot of the information that's in my webinar is also in there if you want to do a little further supplemental reading. In the back is a couple of application notes, and I didn't get into a lot of hardcore applications today actually on purpose, but I did in questions, and either I will follow up directly if it's something technical. If not, one of your local sales engineers would also follow up. We're certainly willing to do conference calls to talk about your specific application and your specific needs in this area. I hope everybody enjoyed today's webinar, and I thank you for joining us. Have a good day.